Happy day! I am here to guide you to understand stack in data structure. Data structure is a way of organizing data in computer memory. Data structure represents the logical relationship between data in the computer memory. We can store data, we can do several operations with the data structure. Data structure has the ordered list of elements. We have several data structures and we are going to see one data structure called stack. Data structure can be divided into primitive data structure and non-primitive data structure. Primitive data structures are the one which are defined by the programming language. We can store a specific data in specific location with primitive data structure. The programmers can give value to the primitive data structure. Examples of primitive data structures are integer, float, character, pointer. The integer data structure can store an integer data and the pointer data structure can store the address of another variable. Non-primitive data structures are the one which are defined by the programmers, where the programmers can store multiple data at random locations in computer memory. Non-primitive data structure can be divided into linear data structure and non-linear data structure. Linear data structure is the one where the elements are ordered in sequential order, and the example of linear data structure are arrays, linked list, stack and queue. Non-linear data structure is the one which does not follow the linear format. The examples of non-linear data structure are graphs and trees. So let us understand what is stack. A stack is a data structure of ordered items such that the items can be inserted or removed only at one end. Stack follows LIFO order, that is last in first out order. A stack is also sometimes called a push down store. Let us imagine that we have a stack of chairs where the chairs can be inserted only from one end and the chairs can be taken out only from one end. A stack is similar kind of data structure where the data elements can be stored, can be inserted only in one end and the elements can be deleted only from one end. Let us see in detail about how this stack works. Now this is the representation of stack in computer memory. Let us assume that the elements are stored in an orderly fashion in an array. So in this example, we have 4 data elements already stored. And stack follows 2 important operations called push and pop. For inserting element into the data structure stack, we follow the push operation, and for deleting element from stack, we follow pop operation. When we want to insert an element into the stack, we have to use a push operation, and for deleting, we will be following the pop operation. Let us take an example and see how stack works. So in this example, we have an array of 5 elements, where an array is declared where it can store at the most 5 elements. And already we have some 4 elements in the array, 10, 20, 30 and 40. Top is a pointer which points to the topmost element in the array. So in this example, the first figure shows that top which is pointing to the topmost element, that is 40. In the next figure, we can see that the element 50 is pushed onto the stack and the top pointer is now pointing to 50. The next figure shows that we want to perform a peek operation. So this operation helps to retrieve data from the stack, but still the data is held in the stack itself, and therefore top is still pointing to 50. The next figure shows how we can delete element or take out element from the stack by means of the pop operation. So in this example, the element 50 is popped out and the stack pointer top is now pointing to the next element, that is 40. So this is the basic operation that we do in stack. Let us see how the push operation works. So this is an algorithm of push to insert an element into the stack. So before we insert element into the stack, first we need to check whether the stack is full. If the stack is full, we cannot insert any more elements. So we need to check the condition stack overflow. So Stack Overflow checks whether the stack is having any space. So we need to check the condition Stack Overflow. So if the stack is not full, then we can enter elements in the data structure stack. And therefore, the very first statement that we use in push algorithm is that check for stack overflow. So if the stack is overflown, then the algorithm will return null. If not, we have to increment the top pointer by 1 and then assign the item to stack of top. And that is the end of your push algorithm. Now in this example, we can see that originally we have 3 elements in the stack, 100, 200 and 300. Let us assume that the size of the stack is 5, where we can store 5 elements. Now we would like to include one more element in the stack by means of the push operation. So what we do now here is that we will increment top by 1 and now top will now point to the topmost element, that is the element next to 300, and then the element 400 is inserted into the stack, and that is how the stack will look, which is shown in the next figure after inserting 400 into the stack. The next operation that we have in stack is pop operation. This operation helps to delete elements from the stack. So before we delete element from the stack, we need to check for stack underflow condition, which means that if the stack does not have any elements, then we cannot perform the delete operation. And therefore, first we need to check whether the stack is underflow or not. If the stack is not underflown, then we can remove the item from the stack. So the very first statement that we do is that stack of top, that is top will be pointing to the topmost element. So that element is retrieved and it is stored in an item. So once the element is stored in a variable called item, top is decremented by 1, and that is the end of your pop algorithm. And once the item is retrieved from the stack, then the item can be used for our manipulation or for updation in our programming. So this figure explains to you how the pop operation works. So let us assume that stack is now declared with the data element with a size of 4. So here already we have 10, 20, 30, 44 elements are stored. So since top will always point to the topmost element, now top is now pointing to the element 40. And we need to understand that stack follows the indexing. This array stack follows the indexing from 0, and therefore stack of 0 is 10, stack of 1 is 20, stack of 2 is 30 and stack of 3 is 40, and therefore top is now pointing to 40. Now we want to retrieve the element 40 from the stack. So when we retrieve the element 40 from the stack and we assign it to item, now top has to be decremented by 1. So top value will now be 2 and therefore top will be pointing to element 30. So in our next figure it shows that now we want to retrieve 30 from the stack. So once the element 30 is retrieved from the stack, top is decremented by 1 and now the top pointer is now pointing to the element 20. So we proceed in this manner, and finally when the top is -1, which means that stack is empty, we don't have any more items to be retrieved, and that is the end of the algorithm. Now as I told you, you have peek operation. This operation refers to retrieving the topmost element in the stack without removing it from the collection of data items. So you can retrieve the data and you can do any kind of manipulation with that value that you have retrieved, but the element will be still present in the stack. So the stack implementation, the stack can be implemented in 2 ways, using arrays and using pointers. Using arrays, when we implement stack, we call that a static implementation. When we implement stack using pointers, we call it as dynamic implementation. So let us see an example of how stack can be implemented using arrays. So in the topmost figure, we can see that we have declared an array of size 6. And already there are 2 elements in the stack, that is 0, at stack of 0 we have 100 and stack of 1 we have 200. And we know that top is a pointer which will point to the topmost element. So right now top is pointing to 200. Now we try to insert an element, that is 300, into the stack. So once the element is inserted, accordingly top pointer is also updated. The next figure shows when we delete element or when we do the operation pop from the stack, we can see that the element 300 is popped out and the top pointer is decremented by 1. So array is a static data structure where we have to define the size of the data structure in advance. We cannot increase or decrease the size of the array during the implementation of the program. So the memory size here is fixed. That is why we say array is a static data structure. And this is one example of how the stack data structure can be implemented using arrays. Now let us see the next example where we try to implement stack using linked list. So in the linked list, we can see here we have collection of nodes, and these nodes are taken from the available pool of nodes. So once we take a node from an available pool, we insert the data in that, and each node in a linked list will have two fields. One is called the data field and the another one is called the pointer field or the next field. So we take a node from the available pool of memory and we try to link that node to the existing linked list. So in the very first figure, we can see that there are already 3 nodes in the list, and these nodes have the data elements 100, 200 and 300. Now in order to traverse through the entire list, we use the top pointer, and there is always the starting pointer called head, which is pointing to the first node in the list. Now this is a scenario where we have 3 elements. Top pointer is pointing to the very first element in the stack. Now let us see how we can insert a new element into this linked list stack. So we have to take a node from available pool of memory, insert the data item 400 there, and we have to try to add the node that we have taken from the available pool to the existing linked list, and we have to move the pointers, make the pointer of the node to point to the next node in the list. Now in this example, when we add 400 in the list, so the top pointer is updated accordingly, and the start node head is now pointing to the node which has the value 400. So here we have inserted a node, we have added the value that we need to insert. Now when we want to delete, we can only delete the value 400 because that is what the stack data structure says, where we can insert the node at one end and we can delete at the one end only. So the very first node that we have inserted, that is the node which has the value 400, is now deleted, popped up from the stack, and the top pointers and the head pointer is updated accordingly. So this is an example of stack implementation using linked list. The advantage of implementing stack in linked list is that whenever we want manipulation or whenever we want any updation or whenever we want to do any operation, we can take a node from the available pool, insert the data, do necessary operation and return back the node so that the memory is free and it can be used for any other program. So that is the greatest advantage of using linked list. So this example shows how stack can be implemented using linked list. Now we have various application of stack. So stacks can be used for expression evaluation and conversion, for backtracking, function call, parenthesis checking, string reversal, syntax parsing and memory management. Now let us take one example, one application of stack, that is expression evaluation. So there are different kinds of expression. We have infix expression, prefix and postfix expression. Infix expression is the one which has the operand, the operator and the operand. Here the operator will be in the middle. In the case of prefix operation, the operator will be appearing first, followed by the operand. In the case of postfix operation, the operands will be appearing, then followed by the operator. So we have 3 different types of expression, and we can use stack to evaluate a postfix expression. So postfix expression is the one which has the operands first, then the operator. So when we follow these steps for evaluating the postfix expression, we can do the evaluation easily without any difficulty. So the first thing that we need to do when we have to evaluate the postfix expression is that we need to read the expression from left to right. So when a number is seen, it has to be pushed onto the stack. When an operator is seen, the topmost or the first two elements from the stack are popped out and the necessary operation is performed. Once the result is obtained, the result is again pushed onto the stack, and this process goes on. So this is an example of evaluating a postfix expression using stack. Now we have the expression like this: 6, 5, 2, 3, these are all called operands, followed by the operator plus, then again we have another operand 8 followed by the operator star, then another operator plus, then operand 3, then operator plus and star. Let us see how this expression is going to be evaluated using stack. So the first 4 elements are operands, and therefore they are pushed onto the stack in the order 6 first, then 5, 2 and 3. Next we encounter an operator. So we pop out top 2 elements from the stack and we perform the operation plus. So when we pop out 3 and 2, perform the operation plus, which comes the result as 5. So the result is again pushed onto the stack. Now the next is the operand. So 8 is pushed onto the stack. The next element is star. Star is an operator, multiplication. So the top 2 elements from the stack 8 and 5 are popped out and the multiplication is performed. So the result is 40. 40 is pushed onto the stack. So next element that we have here is the operator plus again. So since we have another operator here, again we pop out the top 2 elements 40 and 5, perform the operation plus, which is 45, and now the result 45 is stored onto the stack. The next item here is 3. 3 is an operand and therefore we push onto the stack. Followed by 3 we have the operator plus. So the top 2 element 45 and 3 will be popped out and the operation addition will be performed, 45 plus 3, which is 48. The result is pushed onto the stack. The last element that we have in this expression is asterisk, that is star. So here we need to do multiplication of the top 2 elements here. So we are left with only 2 elements now, 48 and 6. So when we perform the multiplication operation 48 and 6, the result is 288, which is pushed onto the stack. And therefore, once all the operands and operators are taken into consideration for evaluation, finally we have the result 288, which is there available in the stack, which can be retrieved using peek operation, or it can be popped out and store the value in the variable for the program to proceed for any processing. So this is an example of how stack can be used for evaluating a postfix expression. So this is how stack can be used for evaluating a postfix expression, and we have many other applications using stack. Thank you for listening to me. Thank you.